Hello again, beautiful IM1 people. We are about to do the thing that I've been hyping logarithms up for, which is solving exponential equations with them. Now you guys solved exponential equations already. You just could only do the ones that you could make bases the same on both sides. So these types of problems are going to be the ones where you can't. There's nothing you can do to make bases the same on both sides, and that's where logs come in. So there's a few things that I do want you to remember. The first thing you need to remember is what this is equal to. Anytime you take a log of a base to its own base, you're really asking yourself, what power of b gives you b? Well, that power is simply 1. So at some point, this is probably going to come into play in that anytime you have a log of itself, you just have a 1. And essentially what you guys are going to do is you're going to cancel out that expression. It's going to be very helpful for us when we see it in a little bit. You also need to specifically remember this property right here, is that if you have a log with a base of an argument, and that argument has a power on it, that property says that we can rewrite it as the same log with the same argument, except that power is going to go into the front with multiplication. All right? And lastly, there is something called natural log. We rewrite it like this. It's called ln. And you'll actually see it on your calculator, usually right next to the log base 10, the common log button. And all that is a log with a base of e. Okay? That log base e is going to come into play pretty much any time that we have an exponential equation that has a base of e. So we're going to kind of have to remember that. Now, the main idea today is that a log is just an operation, just like anything else, addition, subtraction, multiplication, and can be used to rewrite exponents in a more useful way. That's what I've been telling you guys this entire time. And so the real question is, why can't we log both sides? The same way that if you need to move a 3 that's adding on this side over here, you would do it with subtraction, but you have to do it to both sides. If you have something multiplying onto what you want on the left side, I guess that would be your guys' right side, and you want to unmultiply it, you would do it to both sides. You get to do that starting to use log as an operation. All right, and that's kind of our big thing for today. So here's our steps, and before I start talking about your steps, I want to talk about what the goal of those steps are. And the real big goal here is we're going to have exponential equations that have exponents up in the have x's, up in the exponents. And our real goal is to get x, or whatever your variable is, out of the exponent. Okay? That's our goal for today. And these steps are going to help facilitate that for us specifically. So here's the steps. The first thing that you're going to need to do in these these exponential problems, and they might not always need you to do this, but if it's not done already, then you're going to have to do it, is you want to isolate the base with the exponent on one side. Okay, so what we are trying to make happen is we're trying to make something like this happen. You'll have just a base on one side with an x, and this could be like x minus 1, 3x minus 1, whatever, equals everything else. Okay? Now, if that's not happening already, you're going to have to add, subtract, multiply, divide, anything that's not your base with your exponent onto the other side. And once you do that, you're ready to move on to step 2. Now, this is a if and only if. All right, so that's what this stands for. If you can rewrite with the same base like we did before, you should do so. If not, and this is what we're doing today, we are going to what I call hit it with a log. All right, and this is essentially how you're going to apply a log like we were talking about here to both sides, just like if you add 3 to both sides, divide by 10 to both sides, whatever, you're going to log both sides. And we're going to use a common log here most of the time. All right? and we're just going to log both sides of the equation, as in whatever's on the left and the right, we're going to stick the word log essentially in front of it, and then we're going to go from there. Okay? Now, step 3, we have to apply the properties of logs. So some of those properties, I'm just trying to remind you here, is that powers on your arguments, powers go in front. Okay, that's one of the properties that we have to make sure that we are doing. And remember that a log is just a number. Okay, now I'm trying to remind you of that property because you're going to have to move log expressions around. And you need to realize that any log expression is just a number. So if you see like 3 to the x minus log 10, that log 10 is going to be able to move just like if it was 3 to the x minus 10. Okay? You're just going to bring the number with it. Okay? And the last thing you're going to do is you're going to solve for x, as in you're going to move all logs away from x. Okay? Now, this is going to be hard for you guys to remember. I'm going to remind you, or you probably don't know this yet, that logs don't cancel out. A lot of people think they can do that. You're going to get stuff that says like log 10 over log 5. The log part doesn't cancel out and give you a 2. You're going to have to remember that that log is a number, including its argument. Without both of those pieces, none of this works. All right? And then exactly the way that you see it written, you're going to plug it into your calculator. And this is going to be the hardest part for some of you. You have got to watch out for parentheses. Okay? If your calculator opens up a parentheses, you need to close it. Otherwise, you're putting a bunch of stuff into that parentheses that doesn't belong there. So these are essentially kind of what you need to know, the idea that we're trying to do, which is log both sides. Why can't we do that? We can. And here are your steps. It's essentially 4 steps, not including the part where you actually plug in your number, your expression here. This is what I usually call calculator ready form. And you have to actually give me what that thing is equal to. So that's kind of what we're going to be looking at today. Now I have 4 examples, as per usual, that I'm going to show you guys how to do these. I'm hoping that you remember a lot of your properties. That's going to be very important for you. So let me get this board turned around. We'll start looking for some examples and see what we can do from there. Okay. All right, let me make sure the board is centered. There we go. Let me lock this thing so it doesn't move around on me. And here we go. So you're going to start to get equations that look like this. You're going to have exponents. You might have numbers with the exponents. You might have numbers outside attached to your bases, like this one and number 2. You're going to have a variety of different things that you guys are going to have to see. And the steps are going to be the same every time. So let's take a look at number 1. I'm starting you off. This one and this one are actually relatively easy, but I'm going to just go through the list like you guys would do on your normal quizzes. All right? So the first step says get your base and your exponent isolated. Well, here's your base and your exponent. Is there anything else over here with this 6 to the power that needs to move? No, there's not. So we're already done with step number 1. Okay? Step number 2 says if you can write both of these sides as the same base raised to a power, then you should do so. And here's what I mean by that. Can you write 6 and 12, because these would be your bases, this would be like 12 to the first. Can you write 6 and 12 as a base to a power, the same base to a power? No, you cannot. There is no number that when you take it to one power gives you 6 and take it to another power gives you 12. There's just not a number that lets you do that. So this is where step 2 comes in. We can't do that, so we are going to hit it, and I always do this when I'm in the classroom, like I'm hitting it with a baseball bat or hitting it with a log, because baseball bats are made out of wood and logs sound like it's wood. We're going to hit it with a log on both sides. As in, I'm literally going to rewrite this with the word log in front of the 6 and in front of the 12. This is just like if we subtracted 3 from both sides or divided by 5 or whatever on both sides. So it's going to look like this. Log, we're just going to use a common log here because our base is boring, of 6 to the 3x plus 1 is equal to log of 12. Now, what base in my log am I using here? I don't see one. I'm using a base of 10. I'm using a base of 10 because that's all my calculator can do anyways. Okay? So that was step 2. Step 3. Now we're going to apply the properties of log. Well, this is an exponent on our argument, which happens to be 6. So our properties of logs tell us that where does that power belong? Well, it belongs in front. It belongs here. 3x plus 1 log 6 is equal to log of 12. Right? Now, this was our step 3, where we're having to apply the properties of logs. We haven't started to solve anything yet, but remember that any log expression is just a number. If you type log 12 into your calculator, you're going to get just a number. If you type log 6 into your calculator, you're going to just get a number. Now, the first thing I'm going to do, what I'm really looking for, x is not in an exponent anymore. It's down here where we can work with it. So we need to isolate this x so that everything else on the left side moves over there. Now, you have a couple of options here. You could, if you hated yourself, multiply this log in, but what is being done here between the old exponent and this new log power? They're timesing. So what we're going to do first is we're going to get rid of this log base 6 because essentially it's scary and we don't want to deal with it. How do we get rid of a number timesing onto what we want? That's right. We're going to divide on both sides by whatever that number is. Okay? So what is that going to do for us? Well, this is going to cancel out this log base 6 over here, and we will just be left with 3x plus 1, and this is what you guys are going to get used to. This is messy. I do not get to cancel these two logs out and say it's equal to 2. I'm going to leave it just like this, log base 12, or log of 12, excuse me, over log of 6. And now my goal is to get this x by itself. Well, how do I do that? Well, if I did this, log of 12 divided by log of 6, I get just another number. So don't worry about what that side looks like. This 1 and this 3 need to move because they are attached to x and I don't want anything attached to my x. How does plus 1 move? It moves with a minus. How does this 3 timesing onto x move? It moves with division. What am I going to divide by 3 over here? Is it going to be this expression or is it going to be the minus 1? Trick question. It's going to be everything. And this is where you guys are going to run into problems, okay? This is what's going to go into your calculator. So I'm going to kind of do this. This is your calculator, okay? Look at how that's written. It says first do log 12 divided by log 6. You'll plug that in first, close parentheses. It's probably going to open a parentheses on the 12. Don't forget to close them. Then divide by log 6, same thing. Then subtract 1. Whatever you get, divide it by 3. So this is where you guys kind of get a chance to check and see if you're plugging everything in correctly. So when I do this, and I don't solve these in advance, you guys. I do this in real time, so that you can see that I have to do things. So this opened a log with parentheses. I'm going to close it once I plug 12 in. I'm then going to divide by another log of 6, close that parentheses. I hit enter. That gives me a decimal here. Then I say subtract 1, because that's the next part of this whole thing. Then I say divide by 3. What you should get, and I'm just going to write all the decimals here, is x is going to equal 0.1289509357. And these are what your answers are going to look like. If I was teaching you guys in real time and I was actually able to grade your papers, this would suffice. But you have to know how to actually plug these in. So we're looking for the decimal answers here. If you didn't get this, try plugging in this expression a couple of different ways. Make sure you're closing parentheses, doing everything in one step. If you have a Casio, you can probably plug this in exactly the way that it looks. But be careful. If you don't get 0.12895 and some change, then go back and try it again. But keep trying until you get this, and note how your calculator is working. Everyone's calculator works slightly differently. Okay? So that's our first one. Okay? Our second one's going to have a little more to it. So we're going to probably, oh shoot, I might run out of a little bit of room here. So we'll see what we can do. I'm being kind of mean on this one, actually. How mean was I? You know what? We're going to keep this somewhat simple. I'm going to get rid of that -8. It doesn't make that big of a difference for us. Okay? So, here I go. What I am looking for, I have to go back to my steps and think about what my steps tell me to do. I need to get my base with the exponent by itself first. Before I hit anything with a log, I got to get 5 to the 3x by itself. What's over here with it? The -10 is. There was nothing in the first one, but there is in this one. So this -10 has to move. It moves just like you would expect. We're going to add it to both sides. And I'll still have 5 to the 3x is equal to -3 plus 10. That's a 7. Okay? Now, I have base and power equals everything else, which happens to be a 7. So my next step is, can I write 5 and 7 as the same base with different powers? No, I can't. Not easily, at least. So what am I resorting to doing? I'm resorting to hitting this thing with a log on both sides. My base is not e, so I'm just going to use regular common log. All right? 5 to the 3x is equal to log of 7. I'm literally putting the word log in front of this side, and this side. Okay? Now I'm on to my next step, step 3. I need to apply my properties of logs. The whole point of this is so that our exponent goes somewhere we can work with it. And that's what our property lets us do. So what we really have is 3x timesing onto log of 5 is equal to log of 7. Okay? Now, our job is to get x by itself on the left right now. You can do this in one step, you can do this in a couple steps, depends on how you guys see it. Think about this though, what is the 3 and the log of 5? Remember, log of 5, if you plug it into your calculator, is just a number. It's going to be a decimal of some kind. I think it's a negative decimal, in fact. This is just a number, and this is a number, and they are timesing onto x. So how do I get rid of the 3 and the log of 5? I divide by the 3 and the log of 5. That will cancel out with the 3 here, and that will cancel out with the log of 5 here. But if I do this to one side, I do it to the other side. Okay? This is what I'm going to plug into my calculator because I know that my x is by itself at this point. And when I plug this in, I told you guys I do these in real time just like I do in the classroom. Log, where'd my log button go? Log of 7, close parentheses, divided by, and I'm going to open a parentheses here because I have to write 3 times log of 5. 3 times log of 5, close parentheses, close the whole parentheses. That lets me know I'm dividing everything. And I should get 0, and not all your answers are 0, 0.4030206517. If you didn't get that on number 2, try plugging all of this back into your equation or back into your calculator until you get this. This is what we are looking for, okay? And these are actually what your answers look like, okay? All right, number 3. Number 3 is going to be a little bit more difficult. A lot of you are going to forget about this. This looks like it's ready for us to do our third step too, or our second step where we hit everything with a log. But look very carefully. The only thing that actually has a base and a power is the e to the 5x. E is just a number. Okay, it's going to come into play a little later for us. What is the 7 doing onto e? It's multiplying it. So the first thing that we have to do before we hit anything with the log is get rid of the 7 that's timesing onto our e. So how do I untime something? I divide. And that gives me e to the 5x is equal to 42 divided by 7. That's nice. That's 6. Okay. And now I have base with power equals everything else. And it's usually going to be just that, just a plain number on this side. I am ready to hit it with a log. Is my base interesting? Yes, it is. I'm not going to hit it with a regular log. I'm going to hit it with a natural log. And you'll see why in just a second. Okay, so you guys haven't used this natural log for. The only reason to use it is if you see this magical letter, which is equal to a number, called e. Okay, so what do we do now? We apply our properties. We'll worry about this in a second. 5 to the x. That's in a power. Where do powers belong when we're in log form? They belong in front of our log stuff. So we have 5x of the ln e is equal to ln of 6. Okay? But here's what we need to remember. ln e is actually log base e of e. If you type ln e, and you'd have to do ln e and put a 1 on this e, you'll find out that this expression right here is just equal to 1. So what we really have is we have 5x times 1 equals ln of 6. Do I need to tell you when I'm timesing by 1? No, I don't. So this will actually cancel out. And the only thing that we'll have is this. This is much simpler. Okay? Now there's no reason you couldn't hit this with a log base 10 if you wanted to, but it won't cancel out nicely and you'll get a weird fraction over here that we don't want. Okay? So all I have to do is get this, yes, really, right now. All I have to do is get this x by itself. What is the 5 doing to your x? It's multiplying. So all we have to do to unmultiply it is divide it off. Okay? So what do we type into our calculator? That. What does that actually equal to? Well, I don't know, so I'm going to have to figure it out. So I'm literally going to use the ln button for the first time ever. ln of 6 divided by 5. This gives me an answer of 0.353518938. Okay? So if you don't get that, try it a few more times, writing it in this way. If you still don't get it, I'll see you in our Zoom session on Tuesday. Okay? And I don't like the number we have on number 4, so I'm going to make this kind of more interesting for us. I'm going to make this equal to, I'm going to make this crazy. I'm going to make it equal to like 1248. All right? Just so that we don't, and we still might, just so that we don't get a super small number like we keep getting. Okay? All numbers are final. You don't have to go back in and check them like we did for the log equations. Once you have it, they work, I promise you. So what am I going to do? Well, I have to make sure that my base and the power are by themselves on one side, which they are. So all I'm going to do at this point is hit this thing with the log. Well, is my base that cool number e? No. So what kind of log am I going to use? The common log, the log with a base of 10, the one that's on your calculator. So I'm ready to just hit this thing with the log. So it's going to be log of 11 to the 6x minus 2 is equal to log of 1248. Just like that. The 6x minus 2 is a power, so where does it belong? It belongs in the front, and we're going to put it in parentheses like we did with number 1. There's nothing for me to do on this side, and I'm not going to touch it until I get into calculator ready form. Okay? Now, what do I have to do? The x is the part of this that I need to isolate. This expression in parentheses, which used to be the power, is times by log 11. So my next step is to say, let's get rid of that timesing by log 11 by dividing. Okay? That'll cancel out my log base 11. I'm going to have 6x minus 2 is equal to this crazy stuff over here, log of 1248 divided by log of 11. Now I'm just getting this x by itself. That's all that I'm doing. How do I do that? Well, do I move the 2 or the 6 first? Usually we deal with addition or, not usually, we always deal with addition or subtraction first. It's being minused, so I'm going to add. Which of these is it going to add to? All of it, plus 2. Okay? How do I get rid of the 6 that's timesing on, and normally guys I would write this in separate steps, but I'm trying to save time by not rewriting these every time. How do I get rid of this 6? It's timesing onto x. Well, I should divide it off. That leaves me with just x. And what's going to get divided by 6 over here? Everything. Notice that that plus 2 is all a part of that. Well, now I have to plug everything in. My suggestion, do your log division first, then add 2, push enter, then divide by 6. That's going to get you the numbers that you want. So let's see, what do I got here? I got log of 1248, because I'm being crazy, divided by log 11 equals plus 2 equals, I'm still going to get a small number, divided by 6. My answer is 0.82885801. That's as far as my calculator is going to go for the answer. Remember, this was your calculator part. The parts that you need to make sure are coming out correct are these decimals. If these decimals aren't correct, you're not plugging them into your calculator correctly. Okay? I might have some on there that are in what we call exact form, depending on how they do it. Or I might just say do straight up decimals for all of these. Some of these are going to look gross, where they have addition, division here, all divided by something big. Don't be afraid if that happens. Okay? You're going to have to be able to tackle that. Now, these particular questions aren't terribly hard, but the concept is weird to you guys. It's new to you guys. You have to get the practice. So I'm probably going to have about 18 to 20 questions of these, which are going to take you some time, on our quizzes. But remember, your steps. Isolate your base and the power, hit it with a log, move the power to the front of the log, get rid of the log crap, then get your x by itself once you have a nice, easy equation that you guys have used before. Those of you that are, I don't know why I keep mentioning this in the video because they're not watching the video. Those of you that are not watching the videos, I can't help you unless you come to Zoom. Those of you that aren't doing either of those things, I don't know what your plan is, but I am happy to fail those of you that don't get your passing grades on these. The passing grade is a 65%, and I'll write this in my description, but I'm getting a lot of people not doing these. The handful of you in each class that are doing what you're supposed to do, thank you. You're actually making my life easier. And yours, this is the easiest IM2 class you can ever have, and probably ever will have, unless something like this happens again. So please make sure that you're doing your work. Please make sure that you're submitting your handwritten work, especially if I've requested that you do. And hopefully this isn't totally terrible of a topic for you. You will have some weird questions, but they're all going to kind of feel just like this. If you see a base of e, use that natural log, or don't. It's just going to make a crappier expression later. So that's all that I have for you guys today, and I will see you later.